our lesson for today is on arrays. We will first review variables and we're going to take a look at how to create an array, and we're going to be writing a program with arrays. So by the end of the lesson today, you will be able to understand how to declare, initialize, and manipulate arrays in Java. You're going to do this by writing a program involving accessing, updating, processing array element through a loop. So what is a variable in a program? Let's just do a review on variables again. A variable is name for a memory location that stores a piece of data so that you can use this in other parts of your program. Create a variable, you must declare the data type so that the program can properly store the data in the variable in this way. And each variable typically holds one single data piece, and especially the ones that we've been working with can only hold one single data piece. So let's take a look at this example, my name. My name is a variable that has a string data type. So this is what we call declaration of a variable. And then in the second line, we're assigning a value of Hamza to the variable my name. And then in the third line, we're also assigning Charlie to the variable my name. So after running this code, the value that my name will be holding is actually Charlie. So although it was initially assigned to Hamza, this value is replaced by Charlie, which was assigned to my name later than this. So as you can see, this variable my name can only hold one piece of data. So what if you want to store multiple data values in the same variable? And that's when we use an array. Array is a location in memory that stores a set of items of the same type, all under one name. And how can this be done? We're going to be adding a set of square brackets after each data type declaration. So for example, for declaring a variable age with int data type, if we want to make this an array, then we're just adding a set of square brackets after data type declaration. So this way, the variable age can hold multiple age values. And then we can actually do this with any other data types, such as double, float, int, or strings, or more. The reason why we're using an array is to store multiple data values. That's the main reason. And each of the item in the array can be accessed using a position number starting at 0, just like strings. And we can also perform operations with these values very simply. So we're going to take a look at that together. Let's take a look at the steps to create an array first. First, you gotta declare an array, like how you declared a variable. And the second, we gotta give the size of the array. So we call this memory allocation. And then once we have done this, we gotta assign values to the array. One way to do this is this way. So once again, we're starting with the data type declaration, and after that, we're adding a set of square brackets. You put the name of the array right after and make it equal to, so notice how we also have the keyword new here, new data type, which matches with the data type you put over here. And then square bracket, this time around though, you're going to be putting the size of the array. So size is the number of elements in the array. And then step number 3, array initialization. So each element in the array can be assigned to a value separately. And each element can be accessed using the name of the array and using position value. So take a look at how it is done over here. So name of the array and open square bracket and put down the index number. This indicates this is the very first element in the array. The order is really important. A second way to declare or make an array is this way in yellow. So technically, it can be all done in one single line if you already know what values that you're going to be assigning to the array at the time of the declaration. So as you can see, instead of adding this part, we are assigning the value directly to the name of the array. And then take a look at how we are assigning the values. The values are listed inside of the curly brackets. We could also do the same thing in this way. All right, so the only thing that's different is the right hand side over here. It kind of looks similar to the orange method or orange way, but instead of putting the size, we're not putting anything there. We're putting the actual value. We're going to be listing them inside of the curly brackets. The reason why we don't have to provide the size here is because we are already providing all the items that you want to add or you want to assign to each of the variable or each of the element. By giving each value, you're pretty much providing how many items the array needs to hold. So the orange way is only used when you don't know what values that you're going to be assigning to each element. So the yellow or the green ways are used when you already know the values at the time of declaration. The yellow way is more preferred though because it's a lot simpler. So let's take a look at what's actually happening at the time of array declaration and memory allocation. And then one thing that you need to note is this. Once array size is given, it cannot be changed. So the size of the array will stay the same. So let's take a look at an example over here. Int student grades equals new int 5. So that indicates the size. Let me just grab my pen over here. That indicates the size of the array. So by providing the size, the computer will then create a memory space that can store 5 values, like this chart. And then that memory location is named as student grades, which is the name of the array. All right, so now let's take a look at array initialization part. Each element in the array can be initialized separately as follows. So once again, each element can be accessed by putting the name of the array and putting the index number inside of the square brackets. And we're assigning the value of 78 to the very first element. And 55 second, 100 third, and 99 and 80 and so on. So what happens is that once these values are given, assigned to each of the element, this memory space will be filled with the values. Here's another way of declaring and initializing the values. So once again, this can only be done once if you actually know the value of the array at the time of declaration. All right, so let's take a look at another example here. So here I'm using string array. So notice how I put string data type and then I put a square brackets afterwards. And this time around, instead of putting the number directly, I am using a variable to represent the size of the array. And the size of the array is 5. So notice that the size has to be always an int value. And then I am assigning a value to each of the elements in this order. And then here is another way at the bottom, the yellow, green. So yellow and the green are preferred when you actually know the values of the array at the time of declaration. All right, so as I mentioned, you can access each element using the array name and putting the index value of the element. So to access the very first element in the student grades, you would do student grade, square bracket, and put 0 and close square bracket. So let's take a look at each one of the code over here given, and you figure out the output of each code. What do you think this will give you? Okay, that's right. It should be 50. So student grades at the position 1 is 50. Student grade at the position of 5. If you said 100, that's actually wrong. Just count the position number from 0. So 0, 1, 2, 3, 4. So we actually don't have a value at the position 5. So therefore, an error. And what about the last one? So student grades at 0 is 90. Student grades at 3, 0, 1, 2, 3 is 99. So if you add these two values together, you're going to be getting 189. That's right. All right, so now you might be thinking, is there any way that we can grab the size of the array? And yes, there is. And this is what you're going to be using to access the size of the array. So you're just going to simply write down the name of the array dot length. One of the things that you got to be careful is that you don't add brackets at the end. So technically the length that we're using here is an attribute, meaning that it's a variable that actually holds the size of the array. It's actually not a method. So if you think about all methods that we are using, they all have a set of round brackets, whether it is empty or not. But for all variables we have round brackets, we don't. So length is actually a variable that stores the value of the size of the array. So for example, let me just go back to the previous slides. For student grade here, so let's say you don't know the size of the array. This is how you can access the size of the array student grades dot length. So that should provide us a value of 5. Okay? All right, let's take a look at this example together. So we're going to be writing a program, a simple program that calculates an average of student grades. Okay. So here I have a file that I created, and I named it as array example. So just make sure that your file is also saved as arrayexample.java. And then we're going to copy paste the code that's given in the slide. And then also think about how to solve this problem, or what is the main goal that you want to achieve? What is the expected outcome in this problem? It's actually the average that you want to get. Assuming that we're getting integer average, I'm going to create a variable to store the value of average. And I'm going to assign a value of 0 initially because we have nothing in that variable yet. All right, now we're going to be using for loop to access each of the element. So what we're going to do, we're going to be basically adding all of those values, and then we're going to divide that by the size of the array. And then I just mentioned that we're going to be adding all of them, and then we need to have a variable to save the sum of those values. So we are not only needing the average, but we also need sum. And then both of them are going to be initialized to 0. So when you are using a variable for a for loop, you might want to initialize them before you actually use them. So I'm going to create a counter variable. So in this case, this counter variable I is going to be used as an index value. And then we're going to run this as long as the index value is less than 5, which means I can go up to 4, which is the last position value. But we already learned how to access the size of the array. So we're going to be using student grades dot length. And then we are incrementing the I value by 1 each time. And open curly bracket, close curly bracket. And we're going to put the body inside of the for loop here. Okay, we have the value sum. What we're going to do, we're going to reassign the value. Initially, it was assigned to 0, but we're going to add the very first element because we can access each element at a time in each iteration. Okay, we can access each element using the index number I. I is starting at 0. It's looping until I reaches the last position, which is 4. Okay, so do you see what's happening here? So every time the code actually, or the program actually runs this line of the code, it performs the task on the right hand side. So the sum initially was equal to 0, and then you're adding the sum to student grades, which is going to be 90 in the first iteration. So you're going to be getting 0 plus 90, which is 90, and 90 will be stored in the sum. Okay, so this is a reason why you must initialize the value 0. If you don't initialize the value 0, so pretty much something like this, the computer will think, oh, what is the value sum here? Okay, it's giving us an error. It says initialize variable. Because what the computer does, whenever it encounters a line with the assignment operator, and if you have a variable on the right hand side, it likes to access the value of the variable. So sum over here is actually a value. All right? A value, but then the variable sum doesn't have a value there. That's why it's causing an error. The sum variable on the left hand side is actually a variable, it's a container. Okay? It's waiting for a value to be performed, an operation to be performed on the right hand side. That therefore we have to put a value there. So 0 plus student grades. Okay? All right. And then in the next iteration, your I value will become 1. And student grades 1 will be 50. And then 50 will be added to 90, which is the value of the sum from the previous iteration. So it will keep on looping until it reaches 100. So the final sum, so if you want to just quickly test for your program, you might as well just print the value of sum just to quickly check. Okay, so let's just run this. And you can double check your value by actually adding these values. All right, we're getting 417 there. So once again, printing can be done to test your value. Although we're not 100% finished, we can always print it, right? And then we want to calculate the average. So the average is going to be the sum divided by the size of the array, which can be also done by doing student grades dot length. So take a look at what we have on the right hand side here. So because we're working with int value for all of these variables, right, int divided by another int value, you will automatically get an int value. So if you actually want to see a decimal value or more, precise answer, you will need to convert one of them into double. So by putting double in a round bracket, so open and close round bracket, and then put down double in front of the sum. Okay, so we're pretty much converting the sum into double. Or what we can do, instead of actually having an int value at the top, we could actually have double, right? And then we're getting an error here because technically we should be getting an int value here. So we can change this to double. Okay, so now the error is gone. Why don't we print it? And run this. So we should be getting a decimal value, 83.4. All right, and then let's just quickly go over this question one more time. So initially, we are given the array value of student grades. And we initialize the variables that we are going to need for this program, average and the sum. So we could have easily done double over here instead of double over here to make the sum value a double. All right. And then in the for loop, we're accessing each of the element and then adding it to the sum each time. So by the end of the loop, the sum value will be the total of these grades. And then we take the total and then divide it by the length of student grade. And we could have easily done this by putting actual number 5, but instead we're using a variable length or attribute length. And then we're printing out the average. So let's just run this one more time to see the result. All right, so that's it for today. So take a look at the sample code and let me know if you have any questions.